Good everyone, today we are going to learn stoichiometry. So stoichiometry is a quantitative aspect of chemistry. It has two branches, which is stoichiometry of formula and of reactions. So in today's class we are going to do with stoichiometry of formula. Now stoichiometry of formula have sub-solvings, which is the molar mass of a substance and the percentage composition calculation, empirical formula and molecular formula. Please stay tuned as we solve. So under molar mass of a substance, we are going to calculate the molar mass of CaNO3(2). So firstly, we are going to multiply the relative atomic masses, which is standard, doesn't change, with the number each and every element is bearing. So Ca is giving us 40, N, which is nitrogen, is giving us 14, O, which is oxygen, is giving us 16. Ca is calcium. So calcium has no number with it. So a standard rule in calculation is that calcium is carrying an invincible 1 with it. So 40 times 1 bracket plus bracket plus bracket. So nitrogen is 14 times 1. There is no number. Nitrogen is not carrying any number here. Plus oxygen is 16 times 3, 2. We are not adding plus to this 2 because this 2 is directly attached to this by this side. So that is why we are going to use this 2 to multiply what is inside this bracket. Is directly attached to it. Why this calcium element, it is not a number and it's not directly attached to this side. So that's why I'm multiplying to with everything inside this bracket. So is equals to 40 times 1 is 40. Remember our plus, so then bracket 14 times 1 is 14 plus 16 times 3 is what? 48. So 2. So now we have 40 plus 14 plus 48 is going to give us what? 62. This 2 back again is equals to, we have 40 plus, now this 62, this 2 outside is going to multiply the value inside this bracket. So what is inside this bracket is 62. So 2 times 62 is going to give us 124. So we have 40 plus 124. So when we add them together, 40 plus 124 is going to give us 164. So our answer CaNO3(2) is equals to 164 gram per mole. So this is how to calculate molar mass of a substance. I'm going to give you, let's do one more example so you can stick. This is our second example on molar mass of a substance. We have here magnesium tetraoxosulfate 6-hexahydrate. So this is what we call it. So in my next slide I'm going to teach you how to name compounds, and mixtures. So let's begin. Remember, we are giving the relative molecular masses. It is standard. It's not something you just make up. It is standard. It is to be stated in the question. So relative molecular mass of magnesium is 24. That of sulfur is 32. That of oxygen is 16. That of hydrogen is 1. So let's begin first. So is equals to, remember when calculating molar mass of a substance is addition. What we are doing here is addition. So magnesium is 24 times 1. It's not carrying any number. It's an invisible 1. So I'm multiplying by 1 plus sulfur is what? 32 times 1 plus oxygen is what? 16 times, there's a 4 here, so multiplied by 4. Only this 4 only affects oxygen because this 4 is only attached to oxygen, not in front of a number. You see what I mean? Then plus this dot here means plus, even though you may say, I thought it was product, meaning multiplication. No, this dot here symbolizes for addition, is plus. So whenever you're doing molar mass calculation, where there's a dot here or there's no dot, you are adding. Put that in mind. So now plus this 7. Now as there's a 7 in front of this compound, this 7 is trying to tell us that we are going to multiply everything here by 7. I've told you in the last example, when a number is attached to the compound, is multiplication we are going to do, but that doesn't mean we're not going to add our values. You still add our value from this multiplication with to this. So we're going to do 7 wait, they're going to say 7 brackets. So hydrogen is 1, so 1 times 2 plus oxygen is 16 times 1. So we have 24 times 1 plus times 1 plus 16 times 4 plus 7 bracket 1 times 2 plus 16 times 1. So now we have here 24 times 1 is going to be 24, is giving us 24. 32 times 1 is 32 plus 4 is 64 plus 7. So now 1 times 2 is 2 plus 16 times 1 is 16. All we are going to have is 24 plus 32 plus 64 plus 7 bracket. Now 2 plus 16 is what? 18. So we are going to have 24 plus 32 plus 64 plus, now this 7 here is going to multiply everything within the bracket. So what is inside our bracket is 18. So we say 18 times 7, which is equals to 126. So what we are going to have here is equals to 24 plus 32 plus 64 plus 126, which is going to give us what? Let's see, we say 24 plus 32 is going to give us 56. So that 56 plus 64 is going to give us 120. 120 plus 126 is going to give us what? 246 gram per mole. That is our answer. Always put your units. If you don't put your units, you will miss mark. So that is how to calculate molar mass of a substance. Let's move on to percentage composition. So we're going to do calculation on percentage composition. From the question we have calculate the percentage of oxygen in sodium trioxycarbonate 4. So for us to do this, we first of all look for the molar mass. From the last example I gave, we saw how we got the molar mass of other compounds. So this time we're getting the molar mass of sodium trioxycarbonate 4. So Na2CO3 is equals to, so we have the relative molecular masses. Sodium is 23, it's the standard. Carbon is 12 and oxygen is 16. So we say sodium, which is 23, so 23 times 2 because of the 2 attached to it, plus carbon is 12 times 1, there's nothing attached to it, plus 16 times 3 because of the 3 attached to oxygen, which is equals to what? 23 times 2 we have 46 plus 12 times 1 is 12 plus 16 times 3 is 48. 106 gram per mole. Molar mass is equals to, molar mass of sodium trioxycarbonate 4 is 106 gram per mole. It's time for us to look for the percentage oxygen in this question. So we know that oxygen, relative atomic mass of oxygen is 16. So the form, I'm going to give you the formula. The formula is relative atomic mass, divided by the molar mass of the compound times 100 over 1. That is the formula. I derived it myself. So the relative atomic mass of oxygen in the question, you know that in the question oxygen is, so what we're going to do is like CO3, because in the question oxygen is carrying a 3 in it. Then the molar mass of this Na2CO3. From the question we know that oxygen is carrying the 3. I want to write it like this so you can better understand what I'm doing. So from the question we know, from the compound you see that oxygen is carrying 3. When we are calculating for the relative atomic mass, we are going to also multiply the value by 3 because from the question oxygen is carrying 3. So this is going to give us what? 16. The relative atomic mass of oxygen is 60. So we say 16 times 3 1 gram divided by the molar mass of the compound is what? 106 gram per mole. So that's going to give us 16 times 3 will give us 48. So we have 48 gram divided by 106 gram per mole. Remember, by multiplying all by 100%. So this is going to give us 48 divided by 48 gram divided by 106 gram per mole will give us 0.45 times 100%. So when you do 0.45 times 100, this gives us 45%. I decided to take mine in 2 decimal places So the percentage of oxygen in the compound is 45%. Calculate empirical and molecular formula. We have an example here. A hydrocarbon contains 20% by mass of hydrogen and has a molar mass of 30.0 gram. Calculate the molecular formula of the compound. So for us to do this, we're going to first of all look for the empirical formula. Then from empirical formula, we're going to deduce the molecular formula of the compound. So for us to do this, we will state the compound given. So they say an hydrocarbon. And hydrocarbon is made up of hydrogen and carbon. So the hydrogen in the question is given to us as 20%, while carbon is unknown. For us to get the value of carbon, as percentage is 100. Percentage, we know that percentage is equals to 100. So what we're going to do is 100 minus 20%. 100% minus 20% is going to give us 80%. Therefore, our C, carbon, is 80%. That is how we get the missing elements from the question. So now I'm saying hydrocarbon, hydrogen, and carbon. So hydrogen is 20%, carbon 80%. So firstly, we are going to divide their values by their relative atomic mass. So we know that the relative atomic mass of hydrogen is 1, that of carbon is 12. So what we're going to do here is 20 divided by 1, 80 divided by 12, which is going to give us 20. Here is going to give us 6.67. So now the next rule we are going to do here is we are going to divide our value with the smallest value here. Looking at it from 20 and 6.67, which is the smallest? 6.67 is the smallest. So this rule involves us dividing all this with the smallest. So at 6.67 is the smallest, we say 6.6. So we say 20 divided by 6.67. And yeah, we're going to also do the same thing. Anything we do here, we also apply it here. Yeah, 6.67 divided by 6.67. So 20 divided by 6.67 is going to give us 2.99. Yeah, 6.67 divided by 6.67 is going to give us 1. From this, we can say H, which is hydrogen, is equals to 3. Because I said it's equals to 3 because I rounded it up. I approximated. When you do approximation, the closest number, if it's up to 5, you add 1 to this. So I approximated to whole numbers. So as the closest number here, 9 is up to 5, is even more than 5. So I added 1 automatically to this to making it 3. Then carbon here is 1. So therefore, our empirical formula for this CH3 hydrocarbon, empirical formula is CH3. So now we are going to move into solving the molecular formula. So when solving this, you say empirical formula is equals to molar mass. You have to solve it. Empirical formula is equals to molar mass. Sometimes they don't give you the molar mass straight, they will give you the vapor density. For you to get the molar mass, you just simply do 2 times the vapor density is going to give you the molar mass. Then apply same rule, it will give you the answer straight. If you don't give you molar mass, they give you vapor density. You say 2 times the vapor density will give you the molar mass. So now in this question, our molar mass is 30.0 grams. So our empirical formula, this is empirical formula, is equals to molar mass. So C is what? The relative atomic masses of this compound. C is what? We know that C is 12. So 12 times 1 plus H is what? H is 1 from the relative atomic mass. Then so say 1 times 3 because this 3 is attached to H only. Is equals to the molar mass that was given to us in the question is 30 grams. So it's equals to 30. So now 12. So put an N here. N represents the unknown. So 12 times 1 is 12 plus 1 times 3 is 3. N bracket N equals to 30. So now this 12 plus 3 is 15. 50N is equals to 30. So N is going. So we're going to divide both sides by 15. We have N is equals to 2. The unknown is equals to 2. So N is equals to 2. So from this, to get our molecular formula, we're going to say that previous structure we derived from the empirical was CH3. CH3N. Remember, CH3N. So therefore, our molecular formula is equals to CH3N. What we got as N was 2. So these two multiply the C, which is C2. These two multiply carbon, which is C2H6. This is our molecular formula in respective of the question. So therefore, the empirical formula is equals to CH3, while our molecular formula is equals to C2H6. So this of an organic compound, which is an organic compound named ethane. So thank you for watching. Do subscribe, share, and like. Bye.